What's up, guys? My name is Emmett, and I currently attend Northwestern University studying electrical engineering, and I went from a 1350 to a 1510 on the SAT. And I'm going to show you how I use Desmos specifically to achieve a high math score. So the first thing that we're going to go over is make sure that you understand your graph settings, that you are able to change between radians and degrees. This is very important when it comes to trigonometry. Everything in the SAT is going to be in terms of degrees. The default is usually in radians. So if you're solving everything in radians, you're gonna get everything wrong, not even because of you, but because of the calculator. So make sure you're in degrees. Now, besides that, we can actually get into every single topic that the calculator comes in handy for. So here, first of all, we can create constants, right? So we can do like this, whatever. We can also create points. So right here we have constant a comma b, so that's 1 comma 2. So as you can see, it's right there. We can also just do it like this, so we have another point. And then you can use functions. So like certain functions you can just plug in numbers, right? Like mean, median, standard deviation. And then there's others where you need to plug in points. So this is when these become useful, right? So if we want to take the distance between 2 points, then we can put in a comma b. If we want to find the midpoint between 2 points, we can do that as well. Take square roots. So right here, it's just SQRT. This is very common. You should always know that. For every other function that you don't know, so there are other acronyms that you can use. I think like cube root, you can do that. Yeah, CBRT. Now, I wouldn't suggest memorizing all of those. I would just use this. So like if you click this keyboard icon right here, you can see everything here. So, right, absolute value, inequalities, square roots, all these functions, exponents, variables. Now, variables I would never suggest doing here. I would just type it in, x. Now, if you noticed, y is not a function. So Desmos actually by default does y is equal to. So this is actually doing y is equal to x here. So if you just plug in x, then it'll get that. So x plus 3, right? This is a function. Now, you can't do y because y cannot be equal to y. That's infinite solutions. So you would actually have to plug in something like that, where now this is technically negative x plus 3 because this is y plus x is equal to 3. We just move the x to the other side. Functions is where we actually thrive, right? So here are all the stat functions here. So max, quartiles, standard deviations, variance, and so on, right? We can also, there's also our trig functions, right? So we can use those as well. Make sure you use them in degrees, like I said. And then what else would I usually use? There's no calculus, obviously. Our distance, midpoint stuff. Oh, here. So in number theory, we have greatest common denominator, right? That kind of thing. But we have this. Oh, shoot. Okay, let me put it here. So we have this. So you don't need to memorize cube roots. You just plug in the number, whatever it is, whatever the root is, and then your number here, right? So basically, you can always find everything. So my suggestion is to get very comfortable with Desmos and just all these buttons. Like make sure you're familiar with where everything is so that when you don't have to memorize all these functions and type them out. You know what I'm saying? Okay, now when it comes to actually solving equations, right? So like I said, you don't have to put y is equal to. So we can do like this, and then we have this, right? So this has a single solution. This is a single variable system of equations, basically. And we have an intersection here. That is our solution, okay? If we have something like this, where you zoom out, you can tell that because the slopes are the same, but the intercepts are the y-intercepts are different, right? Here you can see the y-intercepts. These are our x-intercepts right here. And you can always click to get the exact point. But as you can see, because the slopes are the same, but the intercepts are different, this is never going to intersect, which means that it has 0 solutions, so no solutions. And then if we took something, well, if it was just the exact same, then it has infinite solutions because the lines are overlapping. You can also write down equations to solve for these, right? So if we wanted to do something like this, so let's delete that, something like this. So 2x plus 5 is equal to something. then this is solving for x here, right? Because 4 minus 5 is -1 over 2 is -1/2. So x is equal to -1/2. And as you can see, x is equal to -1/2, the first coordinate, right? And this is just going to have a vertical line. Vertical lines are not functions. You should know that. But this is our solution because x is equal to -1/2. And if I was to actually write that, right, x is equal to -1/2, that's what it looks like. It's that vertical line. It's not just a point. So as you can see right here. Also, as you can see, Desmos will automatically give you the decimal or fraction. And then if you want to see the fraction of any decimal, right, as long as it can create a fraction, you have to put in the number and then you just go like this. Click this left button right here. It will give you the fraction right here. Now, say you were to do something like this, right? If we like kind of what we did up here, x is equal to, then you no longer get that option. As you can see, if we do y is equal to something, that's a horizontal line, okay? Here it intersects, so therefore that is our solution. Now, we're going to go into inequalities because this is single variable equations. We did that. We did systems of equations. Now we need to deal with inequalities. As you guys can see right here, we have all our inequality symbols right here. So if we were to do like the same kind of function, 2x plus 5 is less than 4. As you can see, it's a dotted line. A dotted line means that it does not include this. So this x is not equal to -0.5. X is less than -0.5. And if you did this algebraically, you would know that. Now, let's say that this is less than or equal to. Now it's a solid line, right? So now it actually includes the -0.5. And if you wanted to, if you had basically a system of inequalities, so let's do something like this, you know what I'm saying? Okay, so here, inequalities do not intersect, ever. This system of inequalities would have no solutions. Now, let's see if it was like this. So, and we don't need to make the slope the same. But essentially what's going on here is the shaded region that is shaded for both is the solution. So the solution would be x is, in this case, it would be the solution for the blue one. X is less than this. Now let's do something like this. Here we have from here, this line to this line is the solution because that is where it's intersecting. So from this blue line to the red line is the solution. So algebraically, if you were to do this, you would be able to find out that x is going to be in between -8 and -0.5. But you don't have to do any work on Desmos. You can literally just graph it and then boom. So it's just the answer would be -8, right, is less than, because it's a dotted line, x is less than or equal to -0.5. And you'll see that this is about to create the solution that I'm talking about. Well, so that's the green. And that's our solution. Okay, now we're going to go into circles. Circles are a little bit complicated because I don't remember learning about the circle equation in my class, or if we did, then I don't remember because we didn't really use it that much. So for circles, we have basically x, so you have your variable, and then minus, plus or minus some constant. Okay, so we'll say a plus, and then it's, and also it's going to be squared, plus, and then we have y plus some constant squared is equal to radius squared. Okay, now we need to have, okay, here you can add slider, right? So our radius is going to determine how big the circle is, right? Okay, b here is y. So this is the transformation vertically. Now, because it's inside the parentheses, right? If it's +1, it's -1. So the center is going to be at -1. So the center is going to be at -1, -1 here, right? The reason why is because we're adding a, which means it's going to the left. So basically inside parentheses, it's like counterintuitive. If you're adding, it's going left or down. If you're subtracting, it's going right or up. So it's counterintuitive. If it's outside of the parentheses, it makes sense. So if it's outside of the parentheses, if it's plus, then it goes up. If it's minus, then it goes down. And if it's outside of the parentheses, it only affects the y, because it's y is equal to whatever your thing is, and then boom. So it's only up or down, not right or left. Right or left has to be with x plus in the parentheses. Now, we can change these. So if it was minus, right? Minus 1 and minus 1, then you can see that it goes to the right and up 1. So then we can make these positive. And then there you go, that's your center again. And when it comes to transformations in general, right? So even if it's like a quadratic, say we have x minus 2, so this means that it's going to the right 2 squared. And then anything outside makes sense. So plus 5 will go up 5. So the vertex is 2 comma 5, right? So it's minus 2, so it's positive 2 because it goes 2 to the right, plus 5, so it goes 5 up. And if it's plus 2, then it goes to the left 2 from the origin. And then if it's minus 5, it goes down 5 from the origin. Now, this is a quadratic function. So if you don't remember a rule, just play around and see what the pattern is until it makes sense in your brain. And then you can move on. Okay, now we're gonna deal with functions, right? So this is what I was talking about. F of x is equal to, and then you have some function. Now, this is the exact same as if you didn't put f of x, because f of x is the same thing as y. The only difference is that you are able to plug in an x. So you could do like f of 4, and then it will give you the answer, right? Because 2 times 4 is 8, plus 4 is 12, and that's how you get that. Now, you technically don't really have to do this. You could just draw the graph, and then whatever your x is, so x is equal to 4, and then the intercept will have 12. Now, another cool feature on Desmos is going to be up here, this plus sign, right? Tables are useful, right? So we can plot data. So as you can see, there's our point, 1, 2, 3, 4. So here we can plot our points, and then you can add regression. So when you add regression, this is going to be our linear regression model, and it gives you the equation right here. R squared and R, this is our correlation coefficients, right? So basically here, the reason why it's 1 is because it's very strong, and it's because all the dots line up on the line, because they make a perfect linear model, which is y is equal to 1x plus 1. So this equation perfectly describes the model. If you add some other data where it's not perfectly on the line, so let's say like 4, 6, then now you'll see that the R's are not as strong, right? So they're still very strong, but they're not exactly 1 because the dots are not exactly on the line. Okay, now for regressions, they are actually pretty simple. So again, if we could use the table again, right? So our here, but instead of adding the regression, we actually just do this. So y1, right? So it has to be y1 because this is y1. Okay, if this was y2, then this would have to be y2. Okay, so it has to match the table essentially. So y2 is equal to, and then we'll keep it at x1 just to prove the point. But this is obviously going to be some kind of linear function, right? Okay, so as you can see here, we have our linear function. Now, the problem is that it's still not showing us our linear regression line. So obviously, without clicking on that, what we can do is we can just add a tilde. So once we add our tilde, then it is going to give us our M and our B. Anyways, that is going to be everything for this video. If you have any other questions, please leave a comment down below and I can answer those. Thank you for watching.